Hello students, this is your physics class. Students, our last topic was refraction of a light, and we done a activity related to refraction of a light with the help of glass slab. So first of all, you have a 2 minute related to your previous homework. You take a screenshot if you want to get solution of last homework. You have to take a screenshot. Practice question number 5.4 on your supplementary book 15. And our last topic related numerical from NCERT book on page number 176. Students, our today's topic is spherical lens. So there are two types of spherical lens according to our syllabus. First of all, concave lens and convex lens. In given slide, we see spectacle, camera, telescope, etc., which is related. In this application we use different type of lenses. So I am play a video related to lens. In this video we have to see how a lens formed and important points related to lenses.
There are two kinds of lenses that are commonly used, convex and concave lenses. We refer to these lenses as spherical lenses. But do you know why they are called spherical lenses? They are called spherical lenses because a spherical lens is bounded by two surfaces. Of these, either of the two or both are a part of imaginary spheres. A convex lens is thicker in the middle and thinner at its edges. However, a concave lens is thinner in the middle and thicker at the edges. Let us represent the spheres that the lens is a part of using its cross section, which is a circle. The center of the imaginary sphere, which the surface of a lens is a part of, is called the center of curvature of the lens. Since the lens is bounded by two surfaces, there are two centers of curvature. They are denoted by the capital letters C1 and C2. The radius of the imaginary sphere, which the surface of a lens is a part of, is known as the radius of curvature of the lens. The radii of the two spheres are denoted by the capital letters R1 and R2. Note that if the surfaces are part of identical imaginary spheres, then R1 is equal to R2. For most of our study, we will consider such cases. The center of a spherical lens is known as the optical center of the lens. It is denoted by the capital letter O. The imaginary line passing through the centers of curvature of a lens is known as the principal axis of the lens. Note that the outline of the bounding surface of a spherical lens is circular. Also, the diameter of this circular outline is known as the aperture of the lens. When the light rays parallel to the principal axis are incident on a convex lens, they converge at a point on the principal axis after refraction. Since the light rays converge after refraction, the convex lens is known as a converging lens, and the point of convergence of the light rays is known as the principal focus convex lens. You can see that the light rays could come from either the right hand side or the left hand side of the lens. Hence, there are two principal foci of the lens, which are denoted by the capital letters f1 and f2. In the case of a concave lens, the light rays parallel to the principal axis appear to diverge from a point on the principal axis of the lens after refraction. Since the light rays diverge after refraction, the concave lens is said to be a diverging lens. Also, the point from which the light rays appear to diverge is known as the principal focus of the concave lens. Similar to a convex lens, in a concave lens, rays can come either from the left-hand side or the right-hand side of the lens. Hence, it also has two principal foci, which are labeled as f1 and f2. The distance between the optical center O of a lens and its principal focus f1 or f2 is known as the focal length of a lens. It is denoted by the small letter f. Let's summarize what we have learned so far. The center of a spherical lens is known as the optical center O. The centers of the imaginary spheres, which the surfaces of a lens are a part of, are known as the centers of curvature C1 and C2. The radii of such imaginary spheres are known as the radii of curvature R1 and R2. The principal axis is an imaginary line passing through the centers of curvature of the lens. The principal focus of a lens is a point where the rays of light parallel to the principal axis of a lens converge or appear to diverge from after refraction from the lens. The distance between the optical center O and the principal focus f1 or f2 of a lens is known as the focal length f of the lens. The aperture of a spherical lens is the diameter of the circular outline of a bounding surface of the lens. Thank you and happy learning.
Student, you have to learn from this video important points related to lenses. So convex lens and concave lens, there are two types of spherical lens. So in your practice book, supplementary book 16 and practice question number 6.1, you have to define these definition according to related video. What do you mean by principal axis of a lens, optical center of a lens, aperture of a lens, principal focus and focal length? In our next lecture, firstly we get a review related to this question. You have to solve their own self with the help of this video. Student, I am going to share your supplementary book page number 16. You have to practice question number 6. But first of all, concept time 6. There are related to convex lens and concave lens. In this slide, we see each points clear with a proper definition. You take a reference from this slide and give answer practice question number 6 of 6.1. So student, if you have any problem related to spherical lens and related to important points which is discussed in video, you have to text me anytime on my personal WhatsApp window. You have to call me also if you not got a point related to this video. Thank you.